Welcome again. In this lecture we'll see how to manipulate images by accessing some pixels, by modifying the pixel value, cropping some region of interest, or splitting channels and merging them, and so on. So let's start. First I need to create a new file here. I will name it .image manipulation .py. First I need to import OpenCV CV2 and import numpy also as np for short. So let's load this image, read it with OpenCV, read. Its name is, here is messy, so I will give it path data messy.jpg. We can convert this image to grayscale by using like gray image cv2.cvt color of that image and saying cv2.color bgr to gray. It will shown as gray as we have seen before. So if I come here and say show gray image and saying gray image, let's show the original too. cv2 show original and call it here image, and don't forget to saying cv2.weights key and give it 0. Yes, I'm saying Python 3, so it will be shown here the gray image and the original image here. We can access all its properties like the shape, the size, the data type, and so on. So if we want just the grayscale image and we don't want to convert it from BGR to gray using this function here, we can load it as a grayscale image from here. We can say it's 0 here and it will load it as a gray image. So if I comment this one and this one and show the image, it will be like that. So the original image is loaded as a grayscale image. We can print also its shape, image.shape, and it will be shown here. So just one channel image, just a grayscale image. Let's load it as a BGR image as it is. From this image we can access any pixel in this image. For example, to access a pixel in the position of say the 100 and 100, for example, the pixel where it is in the 100 in the height, or in the 100 row and the 100 column, it will be, if I print it here, the pixel will be shown here. So its value is 157 in the blue channel, 166 in the green channel, and 200 in the red channel. We can access also, like for example, just the blue channel. For example, if I say the blue pixel and say it's 100, 100 and the 0 one, the first one, and print it here, the blue pixel, it will be shown here as 157. We can access any pixel in this image. For example, which we access is here 100 and 100. We can access a pixel here. We can access any pixel in the image that we want. We can access any pixel from any channel in the image. And we can also modify the value of this pixel. For example, if I modify the red value of the pixel, for example, it will be image 100 100, and if I say here, for example, for the red channel, it is the second in the shape, so it is the third in the shape with the index of 2. And if I give it, for example, it's 255, and how it will be shown here, if I print this, if I access pixel here after I change it and I print it here, then it will be shown here as 200. It was 200 here and now it is 255. If I give it 0, for example, it will be 0. So it is 0 like that here. It is difficult to see its impact here on the image because it's just 1 pixel. So if we want to see an impact of some modification of pixel values on the image, we should access, like, for example, origin of the image to see the impact of some modification of the image. So now let's see how to access a part or origin of this image and modify its pixel values. Let's comment this one here. Let's come here. For example, to access origin of the image, let's say call it ROI, for example, for origin of interest, and saying image like that, and we want to access from the 20 till 200 and from, for example, 100 till 400. And let's show it here. It's just an image like the other one. In show ROI, it is like that. So this is this part of this image which we access here, this region of the image. We can access any region we want in the image. Just be sure that these values are in the range of the height and these values are in the range of the width of the image. So now if we want to change a part of this image or to put this part of the image in another part, we can just say image and slice the part we want. For example, here from 20 to, for example, let's say from 60 to 240, and for example from 140 to 440, for example, and give it this ROI. So now we'll see how it is shown here. So it gives error here because of this, it should be semicolon. And we can see that the ROI here that we have just cut, it's shown here also in this part of the image. For example, if we want to change this part of the image and make it, for example, black or blue, so we can also make it black like that and saying 0, 0 and 0 and run the image or run the code. So this part of the image is now black because we make it 0. If we want to make it, for example, white, we can put here 255 and 255 like that, and we can see it here, it is now white. So as you can see here, the slicing of this image is just like in the numpy slicing, so it is very easy and you can access any part of the image or you can modify it using the common slice in numpy. Sometimes we need to access just one channel, for example, for some processing like histogram equalization, which we will see later. And to access a channel in the image, we can use a function in the numpy which is called split. So to access, for example, each channel separately, the blue channel, the green channel, and the red channel, we can say here cv2.split that image, and we can print here, for example, the b.shape. They all have the same shape because are just the same channel. it has the same shape as the image. Also, all the channels have the same shape. We can also display these channels by saying cv2.imshow. It will show them as grayscale images. So the blue channel, it is B, and if I copy just this one, paste it here. So let's see, it's red, and only here red, and here green, and change here to green. So now they will be shown as grayscale images. So this is the original image, this is the red channel, and this is the green channel, and the blue channel here. So each one has different intensity, depends on the presence of the different colors in these images. You can see that each of these images has different intensities of black and white. As we can split these channels using CV2, we can also merge them using CV2. So if I call it the merged image, it will give just the original image, and saying cv2.merge all the channels B, G, and R, and show here, for example, cv2.imshow merge, and call it here merged image. And if I show it, it will show here the merged image. It's the same as the original because we have just split and merged the channels.